Hello and welcome to the Maths Jedi. This is my third video in the A-level series. This particular video is concentrating on the use of binomial tables. This follows on from my video the other day on binomial distributions, and before that my one on discrete random variables. So if you need to check those out, they're available on my channel. And please do leave a like and subscribe if you're new to the channel. That would help me out a ton. So what we're going to do today is we're going to go through some basic exam type questions, looking at things particularly useful for those of you doing the Edexcel exam. So we're going to be cracking on through some typical questions that you might see and just sort of making our way through some questions types that you will probably see in the exam, and look really about how we're going to handle these things. So let's start off with binomial tables and how they're constructed. Best to start off with an example because then I can sort of talk it through as we go. So this particular screen is talking about a table of probabilities. The first thing to mention about binomial tables is that they're cumulative. So when GCSE came along, you were doing these things called cumulative probabilities or cumulative frequency graphs. You'd have met cumulative frequency graphs for sure, and you would hopefully recognize that those things you add up as you go. So with binomial tables, it's much the same. Each of the probabilities is an add up as you go. So here is a typical table. You can see here it's an extract showing the binomial distribution where the number of trials is 10 and the probability of success is 0.3. And then you can see all the probabilities down here listed. But it's important to mention that these are cumulative. So this one here is the probability of 0. This is the probability of 0 and the probability of 1. This is the probability of 0, the probability of 1 and the probability of 2. This is 0, 1, 2 and 3. 0 to 4, 0 to 5, 0 to 6, and finally the probability of getting 7 will be 1 here. That's 6 plus 5 plus 4 plus 3 plus 2 plus 1 plus 0, and the 7 as well. So all the probabilities added up. So that's important to mention about tables of probabilities. They're always cumulative. Here's a typical question that you might see. Important to mention first of all, as with previous questions, it doesn't really flag that you need to use the binomial distribution necessarily. So be aware that you'll have to make sure that you fulfill those criteria that were listed out in the previous video for binomial distributions. So let's just go through those criteria again, just so that you've got them in your brain. The first one really was talking about, is there a limited number of trials? Well, yes, there is a limited number of trials. Is the case that they carry a particular gene, is it something or not something? So yes, they either carry the gene or they don't. So that's one of the criteria we talked about in the last video. Is the probability fixed? So 1 in 4, that will be fixed across the distribution and that will always stay the same. So hopefully that, and then finally, are the events independent? So does one person carrying a particular gene mean that another person carries a particular gene? Well, it's not clear, but we can assume for this question that they are independent. And so if you've got independent events with fixed probabilities over a fixed number of trials, then you can assume that it's a binomial distribution. In this particular question, we're asked for two things. We're asked for exactly 3 of them carrying the gene and then at least 6 of them carrying the gene. Again, I've pulled out the extract of the probability table here. We'll look more deeply at the probability tables a bit later on, but for now I've just pulled an extract out to look at it to see what's going on. Now in this case we'll ask for exactly 3. So the important thing with exactly 3 is that we have to bear in mind that, of course, the cumulative distribution table looks at 3 plus 2 plus 1 plus 0. So this probability here is not the probability of 3. Actually what this is the probability of 3 plus 2 plus 1 plus 0. So how do I get exactly 3? Well, if I want exactly 3, what I've got to do is take this probability and then take this probability and then work out exactly 3 by taking them away. So what you'll see here on the left is how that's calculated. So you'll see the probability of at the most 3, so okay, the probability of at least 2, or at most 2, and the 2 probabilities are subtracted, and that leaves you with the probability of 3. Because of course this is probability of 3 plus 2 plus 1 plus 0, this probability of 2 plus 1 plus 0, so if you take 2 things away, that will leave you with the probability of 3, and here we're getting a number 0.1339. For at least 6, it's something similar. Again, we use that fact the probabilities add to 1. So we look at the fact that they add to 1. So here, if they're at least 6, they're 6 or more. So if it's 6 or more, that's 1 minus the probability of it being 5 or less. 1 minus the probability of 5 or less. So you can see from the table we can pick that value out, 0.6172 they're taking it away from 1 to get the relative probability here. Let's look at another question. This is an exam style question. Again, just do that little test about whether it's suitable for a binomial distribution. In some cases, as I think this one does, it will ask you to state an assumption needed. So let's just go through that list again as we're going through the question. So it says here that she's estimating the probability that she has to stay late at work. So she's either late or she isn't. So that's certainly a criteria filled. She plans to keep a record over the next 16 working days. So that's a fixed trials. And the fixed probability will stay the same. There's one thing that isn't mentioned here, and that is that there have to be independent events. So the fact that she's late on the first day hopefully doesn't affect that she's late on the second day. So when it says here, state an assumption needed for a binomial distribution, it'll be that assumption that we have to make because all the rest is fairly clear. It'll be the fact that there is independence here going on that makes the binomial happen. Assuming that it is a binomial distribution, what kind of binomial distribution is it? Well, in this question, I hope you recognise that we've got, from the previous video, if you remember, we've got a situation where the binomial distribution is 16 trials. So we can write that like this, so 16 trials, and then the probability of success 0.2. So like the previous video, you can see that's gonna roll out 16 and 0.2. Sorry, it's a bit messy. And we're being asked probability she stays late at least twice. That's 2 or more. The last bit is irrelevant for Edexcel at the moment because we don't have to work out the mean and standard deviation of a binomial distribution for the moment. So I'm going to leave that one out and we won't go through it as an answer. So part A, here's the answer. So we did talk about the fact that it has to be independent, and that's what's stated here. It's important to mention that it has to be contextual. That's analysed here. Always contextual relevant to the question. So the fact that she's late on the first day doesn't mean she's going to be late on the second day. And here's the probability of her getting at the most 2. Let's look at the question again, just to remind ourselves. It was the probability she stays late at least twice. That's 2 or more. So probability of 2 or more will be 1 minus probability of 1 or less. So the probability from the table was 0.1407, it's just here. And you can see they're taking that away from 1 to get 0.8593. Again, I won't go through part C because it's irrelevant for your particular syllabus at present. Okay, let's look at a couple of examples now and crack ourselves through into the book. So I'm going to take this away. We're going to look at what's in the textbook real quick. So we're going to start up with a couple of questions that we can see. These questions are all in the Edexcel textbook and they're all on page 94, I believe. So I'll just double check that and make sure that you've got that understood. So just double check. Yes, page 94. So we're going to look at these questions up here in the top left. So 7, 8, 9 and 10, those 4 questions particularly, I'm going to leave you some to do, but I'm going to go through 7 and 8 today. And the rest of this exercise, it's exercise 6C, I'd like you to do. So please do work your way through those independently. And if you're in my class, I'll send you the answers and I'll send you the shots so you can make sure you can go your way through it. So 7, 8 are the ones I'm going to do. I'd like you to try 9 and 10 at least, and some of the others if you've got the book. If you haven't got the book, then you might want to try 6, 9 and 10 just to make sure you've got it covered. Okay, so let's just first of all look at the question and try to get our head around what the question says. I need to pull up the answer scheme here so I can have a look. Okay, so the first things first, it says the random variable x is variant to a binomial distribution, number of trials 50, and then the probability of success is 0.4. So that's very important to mention, first of all, what particular binomial distribution that is. And it's asking to find some values from the tables. Now, the tables are all standard tables, and I'm going to use the ones that are given to you in the exam. So here's the table in the exam, and I'll pull this to one side so you can see me using it as I go. Now, earlier on I picked out this particular page of the statistical tables just to prove this is the statistical tables. Here's the front page. So this is the statistical tables certificated from 2018. You can download these from the Pearson's website. These are freely available and available to everybody to download, so I would encourage you to do that. It's definitely something you can Google and pick off very quickly because it's helpful to use the tables that, of course, you'll be given in the exam. There's all sorts of formulae in here, things like pure formulae and statistical formulae, but we're going to be concentrating on these tables at the back here, primarily focused on these values. So we just need to crack ourselves through this. So that's what we've got to. So this is the one we're losing. So binomial distribution, number of trials 50. That's why I'm picking out the number of trials 50. And we're looking at the one where the probability of success is 0.4. So we're looking at this column here. The probability of 0.4. Okay, I'm going to pick up my pen. So what we're going to look first of all is we're going to just make sure we've got ourselves understanding what the question's asking for. So the question's asking for the probability that at the very most k is 0.05. Now that first of all is important to mention that it's a challenge because we're being asked for at the very most the cumulative probability of being less than 0.05. So over here on this particular column, we're going to go down the list and just pick up the one that's less than 0.05. Be careful to get the number of decimal places right, because that's always a common error, making sure that we get that understood. So you can see I'm going to go my way down the list, and I think this one here, so I'll just circulate that one. These two here are worth looking at. So this one here is 13 and 14. Okay, so 13 is 0.0280 and 14 is 0.0540, but we want less than 0.05, so it's 0.0280 that we need. That must mean the probability is 13. So it's 13 in this case that we need. So we're going to put that over here, I think. So that's the answer to part A. This one here is a bit different. This is asking for the probability of more than something. So we have to use that fact that probabilities add to 1. So over here in the table, let's see what I can do to find that. So let's have a look and see. So down here, I see now these are the two values that are concerning me. Okay, and those values correspond to 27 and 28. Okay, a bit messy, but hopefully you can see that. So 27, first of all, is 0.9840, and 28 is 0.9924. Now, a reminder that probabilities have to add to 1. What we're really looking at is this. We're looking for the probability that is cumulatively to the value where it is less than 0.01. Now, for this to be less than 0.01, we need this to be more than 0.99. And the only one that's more than 0.99 is this one, 0.9924. So it's 28 that will go in here. And so it's 28 is the smallest number R. Oh, sorry, this one, 28. So the first one, 13, second one, 28. Okay, let's just check the answers. So here's 13 and there's 28, and you can see them doing the calculation there. They're seeing that it's 1 minus 0.9924, and they're getting the 28 and the 13. The second question, question 8, I want to go through is looking at a different binomial distribution. So you can see this binomial distribution is number of trials 50. I'm going to look at the one that's number of trials 40. So I'm just going to flick back a page to get this one, number of trials 40. And this time we're looking at the probability of success being 0.01. So it's going to be this column that interests me, because that's where the probability is 0.01. We're looking at that, first of all, a very easy question here to look at, probability of less than something being 0.02. So something being less than 0.02. So this time it's important to mention that it's strictly less than. So remember, these cumulative probabilities are looking at less than or equal to. That's important. So we have to make sure we've got that understood. Now this first probability is probability of it equal to 0. So probability of equal to 0 is 0.0148. The probability of it being less than or equal to 1, so looking at this one here, that's going to be the probability of it being equal to 0 and the probability of it being equal to 1. And we want to know where it's less than k. So if it was less than 1, we'd only want the 0 on its own. So the probability of less than 1 is the same as the probability of of equal to 0. This is because it's a discrete random variable, so you can either be 1 or 0. If it's less than 1, if it's less than 1, sorry. Oops. Then it's important to mention that it's just going to be this one here, probability of it being equal to 0. And we know that one here is 0.0148. So less than 1 and the probability of equal to 0 is the same. Okay, less than or equal to 1 will include the 1, and that makes it more than we need. So we want it to be 0.01408. Okay, so this property here, the largest value of k such that p is x less than k will be 1. This one here, the smallest number r such that p is x is more than r. Again, we're going to use that fact of 1 minus again. We're looking for 1 minus 0.01, that's 0.99. So we're looking for where 0.99 occurs. So in a similar way to the previous question, we've got two values in question here, these two. We want the one that's more than 0.99 for the same reason that's in the previous question. So the same reason as before. This is the one that's more than 0.99, so 9 must be our answer here. So this is going to be 9. So for the property of between 1 and 9, so this is x between 1 and 9 here. Now remember, these are cumulative probabilities, so this is looking at the probability of it being less than or equal to 9. So that's all the probabilities. Probability of 1, 2, 3, all the way up to 7, 8 and 9. So the cumulative probabilities added all the way up to there. We want the ones that are between 1 and 9. So if you put a little box around there, which values do we have to exclude? We have to exclude the value that's 0. So what we're going to do is look at the cumulative probability all the way up to 9. That's 0.9949. And we're going to take away the value of 0 because that one's excluded from our range. That leaves all the other probabilities in the loop. And that one was 0.0148. So 0.9949 and then 0.0148. I'm just going to get the calculator up to show you what that makes. So here is my calculator. Let's move it into center here. So we're going to do, again, the two probabilities I have are 0.9949 and I'm going to take away 0.0148. And that gives me 0.9801. We're going to check our answers now. So remember earlier we talked about probability of it being less than 1. So you can see that answer highlighted here. And then a little bit later on we talked about part B. The smallest number was 9. So let's double check that. That's on the next page. So that's up here. This is 9. There's 9. And then lastly, the 0.9801, which is still there in the top left-hand corner. So just show you that, 0.9801. And you can see it highlighted here. It's quite tricky, these cumulative probabilities, so I definitely would let you and encourage you to have some practice of those. It's important to make sure that you've got this really nailed down because it's quite a tricky little topic to be able to do. So it's important to make sure that you have got it nailed. I'd encourage you to do exercise 6C in the book. That's where this is coming from, and as I said, it's on page 94. Please do make your way through that, and then the next video will be on a mixed exercise, which is towards the end of this chapter, so we'll look at that together in our next lesson. For now, thank you very much for watching. Hope you have a really good rest of the week. Goodbye.